Hi, everybody. Today we're going to talk about catalysts and how they work within multi-step problems. So right at the bat here, we see a potential energy reaction progress graph, and this is without a catalyst. It's a single step. There's no intermediate steps. We get one bump. In a catalyzed multi-step reaction, here we get multiple bumps. And these bumps would be lower if they're on this one. They would go like this to show that it have lower activation energy. Here, what we need to do is we need to break it down to its component parts. So there's two parts to this. There's the catalyst, and then there's the intermediate. We're going to add, so this would be the reaction without a catalyst. This would be the reaction on the bottom with the catalyst. And what we're going to do is we're going to add hydrogen ions here, or protons, to this. When we do that, we add it to our acid here. What we get is this compound. This compound comes down to row 2, and you're going to notice that it's going to cross out. Okay, because a intermediate is found on the product side first and then gets canceled out on the next reactant side. We then break this apart to form the water because we needed water. Okay, this compound comes down, it gets broken, it gets taken out, and this will break apart to form the hydrogen ion, which is our catalyst, and the CO. So we have one HCOOH here, and we have one of those that didn't get canceled out, so it comes down to the bottom. We have one water here. We have one water here that didn't get canceled out. It comes down to the bottom. And we have one carbon monoxide that didn't get canceled out. It comes down to the bottom. The catalyst starts on the reactant side and ends on the product side. It gets regenerated. It is not part of the reaction, but it makes the reaction go faster. So catalysts are always first found on the reactant side and regenerated on the product side. Intermediates are always first found on the product side and then canceled out on the reactant side. So here I have H2O2, breaks down into 2H2O and O2. So this is my uncatalyzed reaction. We're going to add iodine to the H2O2. Okay, that disappears and I form water plus this compound here. This compound here comes down to the next level, gets canceled out. I have to add another H2O2 because I need 2 in total, and I've only added 1 here, so I add another one. That forms another water and O2, which you can see down here below. The slowest of these steps, the one that is the highest, this is the rate determining step. Okay, and the rate determining step will tell you the slowest part of the catalyst, and it tells you how long it's going to take for this reaction to occur. I hope that helps, and we'll talk next class.